Pollution. What is pollution? Well, pollution is the residue, remainders, and leftovers of the original source. Sometimes those remainders, leftovers, mix with other things and can create particularly toxic results. This occurs when more waste is added to the Earth system than can be readily absorbed. More is going in than coming out. Do you remember the four components of the Earth system? Do you remember? Here's what they are. The air, which is the atmosphere, the land, which is the lithosphere, the water, which is the hydrosphere, and life, which is the biosphere. Let's start with air pollution. Do you want one of those next to your house? Neither do I. Here's some of the main pollutants: carbon dioxide, carbon monoxide, sulfur dioxide, methane, ozone, and particulate matter, which is also known as aerosols. Particulate matter is really, really tiny, solid material that floats around the atmosphere and acts like gases in a way. And these things can create what's called photochemical smog, or smog. In Los Angeles, we know exactly what smog is. It's air pollution. So when I was in New Delhi, I took a screenshot on my phone, and if you see down at the bottom, it says air quality 503, hazardous. Okay? So PM 2.5 is particulate matter 2.5. It means that the particles, the aerosols, these small solid objects floating around in the air that are invisible, are 2.5 microns or smaller. This is a particularly dangerous thing for breathing. Almost acts like little razor blades going into your lungs and screwing your lungs up. On your phone, you may very well have, if you have the weather, the air quality index. Notice that if your air quality is 0 to 50, it's good. Go out and have a good time. Even 51 to 100, which is moderate, not too bad. Look down at the bottom. The scale only goes to 500, and I just showed you in New Delhi, India, it was 503. New Delhi is one of the most polluted cities, large cities on Earth, and it's because they burn everything. Coal, oil, plastic, wood, you name it, anything that can be burned, coal, it's all getting burned over and over. Oil burned, plastic burned. That's what's happening. Okay, so I need to do a little science with you. Here's what it is. The greenhouse effect. The greenhouse effect just does this. It describes the fact that shortwave radiation from the sun, that's the energy that comes from the sun, easily penetrates the atmosphere without heating the atmosphere. Meanwhile, that shortwave radiation is absorbed by the surface of the planet, which then emits longwave radiation. The nature of the gases of our atmosphere is such that they are really good at absorbing long-wave radiation. So we actually heat from the ground up, not from the sun, believe it or not. And particular gases are greenhouse gases. They're good at absorbing long-wave radiation and maintaining heat in the atmosphere. Now, we need heat in the atmosphere. We're 93 million miles away from the sun. We need these gases. We just don't want too many of them. It's like many studies have been done. A glass of red wine a day, provided you're not an alcoholic and you don't have alcoholics in your family, is good for you. 20 bottles of wine, not so good for you. This is the way the greenhouse gases work. The primary ones for our purposes are carbon dioxide, which is CO2, sulfur dioxide, which is SO2, and methane, which is CH4, combined with the particulate matters. And you can see, your car works like this. If you park your car outside in the sun on a sunny day and leave the windows rolled up and come back a couple of hours later, what happens? It's very hot inside the car. This is why you don't leave a child or a dog in the car when you go out and go shopping, because it gets exceptionally hot inside the car. What's happening is the short waves come in through the glass. They heat up the interior of the car, like your seat and your dashboard. Those things, the seat and the dashboard, let out long wave radiation, which then is held into the car because the glass operates something like the way the greenhouse gases operate. This is New Delhi. Hey, take a look at that. That's air pollution. Can't see very far. This, I kid you not, this is at New Delhi Airport. when we were getting ready to take off to fly to Amritsar in India, that's air pollution, man. That is not fog. That's air pollution. Wow. Now, this can come from a lot of sources, industry, automobiles. It can also come from burning down the forest, deforestation, which is a pretty common thing in tropical areas where there is tropical rainforest, probably most famous in the Amazon. Now, the problem with doing this is that plants and animals have a symbiotic relationship on this planet, where plants absorb carbon dioxide and produce oxygen. Animals like us produce carbon dioxide and need oxygen. So when you go out and burn down the forest in order to make mostly farmland, what happens is you not only kill off something that can absorb excess carbon dioxide in the atmosphere, but in addition to that, you're producing more carbon dioxide, because anything that was alive, when you burn it, is going to produce carbon dioxide and other gases as well. So global warming is obviously the problem that people are concerning themselves with regard to air pollution. Probably the main gas that contributes to global warming is carbon dioxide, atmospheric carbon dioxide, which is natural in the atmosphere. In 1880, carbon dioxide accounted for about 300 parts per million of the entire atmosphere, 0.03%. In 1989, about 100 years later, it was 340 parts per million, 0.034%. In 2021, 403 parts per million, 0.0403. What happened? What changed over that period of time? Why is there more carbon dioxide? Well, it's because of energy consumption. First of all, look in 1820, we were not consuming that much energy, and mostly it was coming from biofuels. Then, as industrialization progressed, you can see in the late 1800s, it really begins to hit the planet. As that happens, we begin to use more coal, more oil, more natural gas, all of which are fossil fuels and produce a lot of greenhouse gases. This is the United States. You saw this one before. At first, we were using biofuels, wood, but then you can see as we begin to go through the Industrial Revolution, our coal, oil, and natural gas consumption increases significantly, which produces even more greenhouse gases. That's what happened. That's how we produced more carbon dioxide in the atmosphere. Now let's take a look at land pollution, lithospheric pollution. Where does your garbage go? You know where it goes? More than half goes into a landfill. And as solid material in landfills decays, it can produce leachate, which is like a soupy stuff that then seeps down out of the landfill and can contaminate groundwater. The number of landfills in the United States has actually decreased since 1990, because back then, and then going back to the beginning of time, there were sort of city dumps where you just could dump material. But there are fewer now, but they're much larger, because this allows concentration and control. And the control, which is government control, makes sure, or is at least supposed to make sure, that there isn't as much leachate, that toxic chemicals don't get into landfills, and that the landfills themselves don't leak out all over the place and cause huge problems. Nevertheless, do you want that next to your house? I don't want that next to my house. So as landfills have grown, of course, they make smells, so they're unpleasant. They're unsightly, and problems can happen. What methods are used to decrease solid waste? Well, incineration, so you can burn all of that solid material, and by doing that, you decrease the size of it by about 3/4, then that ash can be dumped into landfills. But the problem is that, that may slow the necessity for new landfills, but incineration creates air pollution. So recycling and composting, these are probably the ways to do it. If you look at the left-hand side, you can see recycling. We all know that symbol. Then composting. If you don't know how to compost, it's very simple. I do it at my house. You just take the refuse that comes from your kitchen, so organic material, and just dig a hole and bury it. And that's it. And worms are going to come because they're going to be happy to have that, which increases the quality of your soil. In 1960 in the United States, we recycled about 6% of our trash. By 1980, it was 10%, 1990, 16%, 2000, 29%, 2017, 35%. It's getting better, huh? 2018, it went down. What's that about? Well, this partly has to do with our relationship with China and the Chinese being unwilling to take all of our recycling, because a lot of it goes to China, especially things like cardboard boxes, goes there, and then they turn it into reusable materials. The EPA, which is the Environmental Protection Agency, estimates that as much as 75% of U.S. waste stream, so our waste, our solid waste, could be recycled or reused or composted. We're doing in the 30s. What about water pollution? That looks pretty ugly too, doesn't it? There's three main sources of water pollution: industry, municipal sewage, which is like the stuff that comes out of your toilet when you flush your toilet, or your bath water, or whatever, your sink water, and agriculture. Which of those three do you think contributes the most to water pollution? Globally, agriculture. Yep, probably didn't think that. In the United States, farming is the largest polluter of runoff, which is streams and rivers, second largest polluter of wetlands, and the third largest of lakes. It's because of the fertilizers and chemical enhancers that are used on farms, pesticides, herbicides, and the animal waste itself, stuff that comes out of the back end of the animal, which then seeps into the water table. Globally, about 80%, check that out, of wastewater flows untreated back into the system. Now, in addition to that, of course, refineries, landfills, septic systems, spills, all of these things can contribute to water pollution. Now, we classify water pollution in two ways: as point source, which means the pollution comes from a specific location, and non-point source, that means the pollution comes from a large diffuse area. Take a look at those two pictures carefully. Which one is point source pollution and which one is non-point source pollution? Answer is, there you go. That stuff washing up on the beach comes from all over the place. The Deepwater Horizon disaster, well, it's coming from that particular oil well. And then, of course, there's ramifications for life, right, for the biosphere. On the left-hand side, you can see this is forest die-off because of acid precipitation. The pelican in the second picture doesn't look too happy. This is actually from the Deepwater Horizon disaster in the Gulf of Mexico. The third picture there you can see is along the Nile River. If you look up here in the background, you can see this is their trash dump. You can see these women are all washing their clothes in the Nile River. In addition to that, you can't see it right here barely. There's a woman carrying up buckets of water up to her house to use. And then in this last picture over here, I mean, let's face it, nobody wants their kid in that.